Belajar je, Papa.
Hei, kebenaran datang sini bukan nak belajar lah. Kebenaran nak mulakan pekerjaan baru di MMU. Bye. Tata Titi Tutu.
Cik Papa, dah bersedia untuk hari pertama bertugas sebagai kaunselor MMU?
Sudah tentu. Kaunselor kebenaran tak pernah tak sedia.
Tumpah tanya, boleh tak terangkan tentang kemudahan yang ada dekat MMU?
Hai, buat apa terangkan kalau boleh tunjuk terus kan? Biar kebenaran jadi tour guide kamu. Jom! Inilah dia perpustakaan digital Siti Hasma.
Wah, siap ada kafe.
Perpustakaan ini dibuka 24 jam. Sorry ya.
Lepas tu, apa lagi kemudahan yang ada dekat sini?
Ada banyak lagi. Jom ikut kebenaran. Dah sampai pun ke studio green screen. Ada studio mocap. Mak Mas 5G pun ada. Lepas kelas boleh ke gym untuk bersenam. Atau ke kolam renang bersaiz Olimpik untuk berendam. Jadi, adakah kamu berminat nak belajar di MMU? Wahai anak muda.
Ya, saya rasa MMU universiti yang terbaik untuk saya.
Kalau macam tu, isi borang ni dan daftar sekarang. Isi cepat.
Tapi, saya belum habis sekolah lagi.
Tak apalah. Yang penting, kamu ada cita-cita yang tinggi. Tata Titi Tutu.
Macam mana Cik Papa? Seronok tak hari pertama sebagai kaunselor MMU?
Memang seronok. Kebenaran tak sabar nak membimbing anak-anak muda lain untuk mencari kebenaran.
Baguslah. Sebab ada ramai lagi yang mahu kebimbingan Cik Papa ni.
Ramai lagi. Pilihan yang terbaik untuk masa depan kamu. Carilah kebenaran di MMU.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam perpaduan dan salam Malaysia Madani. Syukur kita kepada Ilahi kerana dengan izinnya dapat kita bersua kali ini dalam satu seminar ilmiah bertajuk Teknik Menjawab Stpm. Seminar ini akan berlangsung selama 6 hari mengikut tarikh yang telah ditetapkan dan merangkumi 6 mata pelajaran iaitu pengajian am, perakaunan, fizik, pengajian perniagaan, ekonomi dan juga matematik T. Jadi hari ini pelajar-pelajar semua akan berpeluang mengikuti pelajaran untuk tajuk fizik. Okey, sebelum kita lanjutkan acara kita hari ini, saya ingin mengucapkanlah terima kasih kepada Jabatan Pendidikan Negeri Melaka dan juga Universiti Multimedia selaku penganjur bersama seminar ini, serta tak lupa juga kepada seluruh pelajar dan guru-guru di luar sana yang sedang menonton secara online di media sosial kami iaitu di Facebook dan juga YouTube di channel Study@MMU. Okey, pelajar-pelajar semua, kepada yang masih belum subscribe channel tersebut, sudi-sudilah subscribe channel tersebut ya. Kerana di situ kami akan memuat naikkan segala fakta-fakta ataupun maklumat-maklumat terkini yang berlaku ataupun yang ada di MMU. Okeylah, semoga kita semua memperolehi manfaat yang berguna dari seminar ini, insya-Allah. Okey. Bersama saya moderator anda Maizan bin Mahat. Sebelum saya memperkenalkan penceramah kita yang cerdik lagi bijaksana hari ini, izinkan saya berkongsi sedikit maklumat kepada pelajar sekalian mengenai MMU. Mungkin ada di antara pelajar di luar sana ataupun guru-guru masih tidak tahu sepenuhnya apa yang ada di MMU. Jadi peluang ini kami kongsi bersama agar semua dapat tahu dengan lebih mendalam lagi tentang Multimedia University ataupun nama singkatnya kita panggil MMU. Izinkan saya share maklumat di sini ya. Okey, selamat datang ke Multimedia University. Okey, sebagai permulaannya, sejarah penubuhan Multimedia University ini bermula tahun 1997 dan diberi nama pada waktu itu adalah Universiti Telekom dan kini ditukar kepada Universiti Multimedia. Universiti Multimedia adalah salah sebuah universiti swasta pertama di Malaysia dan ia adalah government link university. Kalau dalam bahasa Melayunya dipanggil universiti berkaitan kerajaan ataupun milik kerajaan. Jadi apa maksudnya GLU kat sini? Maksudnya apa-apa proses ataupun program yang kami lakukan di sini haruslah memenuhi atau mengikuti ciri-ciri dan panduan yang ditetapkan oleh kerajaan lah. Maksudnya kita tak boleh lari dari garis panduan tu. Okey. Di Multimedia University, kita mempunyai 2 buah kampus, iaitu satu di Melaka dan satu di Cyberjaya. Okey. Baiklah, dari segi pelajar pula, selain daripada pelajar pelajar tempatan, kita juga mempunyai pelajar antarabangsa. Okey, setakat ini kita mempunyai lebih daripada 1000 pelajar antarabangsa dan lebih daripada 50 buah 6 negara dan kebanyakan mereka adalah dari Bangladesh, Egypt, Yaman, Indonesia, Saudi Arabia, Sudan, Pakistan, China, India dan Jordan. Secara keseluruhannya pelajar-pelajar ini ramai di kampus Cyberjaya iaitu 78% dan Melaka 22%. Okey, baiklah. Dari segi fakulti, multimedia ini ada 2 kampus dan jumlah fakulti kedua-dua kampus ini adalah 10 buah fakulti di mana kita ada 6 domain utama iaitu engineering, iaitu kita ada law, kita ada IT and computer science, kita ada communication, kita ada account, business and management dan juga kita ada bidang kreatif iaitu kreatif multimedia dan cinematic art. Jadi ini adalah bidang-bidang yang kami khusus dan ia adalah permintaan industri. Maksudnya dekat sini pelajar-pelajar yang mengambil bidang ataupun penggajian di MMU, apa-apa yang ditawarkan adalah mempunyai berkaitan dengan keperluan industri. Okey, mungkin ada pelajar di luar sana ingin belajar tapi ada masalah dengan kewangan. Tak perlu risau, di MMU kita juga ada menyediakan scholarship dan juga financial aid bagi membantu pelajar-pelajar untuk meneruskan cita-cita mereka untuk sambung belajar. Okey, kalau pelajar ada kesempatan untuk pergi ke laman web kami, boleh klik di bahagian scholarship dekat sini dan terdapat senarai banyak penaja-penaja yang menawarkan ataupun memberi tawaran kepada pelajar untuk menggunakan ataupun mendapatkan scholarship daripada mereka. Walau bagaimanapun ia bergantung pada terma dan syarat yang ditetapkan oleh mereka lah sendiri. Okey, itu scholarship. Untuk yang di MMU sendiri, kita ada juga ia panggil scholarship, dia panggil kita punya internal scholarship. Jadi kita ada yang MMU President Scholarship, kita ada MMU Merit Scholarship, kita ada MMU Talent Scholarship. Okey, dari segi MMU President Scholarship kepada pelajar STPM, okey, dia boleh mohon untuk sambung ke degree dengan syarat dia mestilah dapat 4 A's. Maksudnya excellent lah dia punya keputusan dan dia tanggung 100% tuition fees, tak termasuk asrama Okey. Okey, selain daripada itu kepada pelajar-pelajar yang aktif dalam sukan ataupun mempunyai talents, okey, juga berpeluang untuk menggunakan kemahiran ataupun dia punya talent tu untuk dapatkan discount scholarship daripada pihak MMU. Kita panggil MMU Talent Scholarship. Okey, selain daripada itu MMU juga mempunyai yayasan. Kita panggil dia Yayasan Universiti Multimedia ataupun nama singkat dia YAM. Okey, salah satu scholarship ataupun yang ada pada YAM adalah Ibnu Haitam. Kalau untuk pelajar STPM, dia punya purata nilai PNGK tu kan perlulah 3.0. Jadi apa yang ditawarkan adalah tuition dan dormitory fees, lepas tu living allowance, book allowance dan juga student development program. Okey, boleh layari maklumat lanjut di yam.mmu.edu.my. Okey, antara selain dari itu financial assistance juga. Okey, sorry. Yang kedua adalah skim fisabilillah. Ini untuk golongan Muslim B40, boleh mohon juga, boleh iyam. Dan juga for non-Muslim, kita juga ada memberi peluang kepada mereka di Yayasan Universiti Multimedia. Okey. Okey, selain daripada itu, pelajar-pelajar juga berpeluang memohon Yayasan Telekom Malaysia. Okey, untuk maklumat lanjut bolehlah pergi ke Yayasan Telekom Malaysia di www.tm.com.my/yayasan-tm. So apa yang dia tawarkan adalah tuition fees, monthly stipend dan juga books and apparatus allowance. Maksudnya pelajar akan dapat bayaran tuition fees dan juga bayaran ataupun pocket money lah setiap bulan dan juga duit buku dia akan beri. Okey. Okay, selain daripada Yayasan Telekom Malaysia tadi, kita ada juga program ijazah dalam negara. Okey, boleh mohon juga di sini. Okey, selain daripada itu, pelajar-pelajar juga berpeluang untuk bermohon dengan pihak MARA. Dia panggil program TESP ataupun Tertiary Education Sponsorship Program. Okey, baiklah. Okey, selain daripada itu, kalau dah tak dapat apa-apa, susah nak dapat, kita ada lagi satu option, kita panggil PTPTN. Yang ni adalah pinjaman dan secara keseluruhannya PTPTN ni dia bukanlah memberi pinjaman 100%, dia bergantung kepada pendapatan ahli keluarga dan juga kategori lah. Okey, walau bagaimanapun kalau student itu berjaya mendapat keputusan yang terbaik, biasanya dia akan boleh tukar daripada pinjaman kepada scholarship beasiswa. Bergantung pada syarat yang dah ditetapkan. Okey, yang ini adalah permata dunia ataupun kalau kita punya pelajar, alumni ni, kita gerari MMU, pelajar MMU kita panggil permata dunia. Jadi ini adalah orang kata pelajar-pelajar yang telah berjaya, pelajar-pelajar MMU yang telah berjaya di luar sana. Contohnya Muhammad Nizam, ini adalah pelajar Fakulti Kreatif Multimedia. Dia telah menubuhkan sebuah syarikat animasi dipanggil Animonstar. Kalau tuan-tuan atau pelajar-pelajar semua tahu yang sekarang ni yang cerita yang Papa Zola, benda-benda macam lah yang sekarang ni yang tengah top macam Encik Usamah Zaid ni adalah juga daripada Fakulti Multimedia. Dia juga mempunyai satu syarikat animasi dan antara filem yang ataupun animasi yang telah dilakukan adalah Ejen Ali. Okay, begitu juga dengan Gas Abu Bakar, dengan yang lain, dengan Tan Huilin, Ho Sujuan dan juga Nur Helmi. Mereka juga mempunyai maksudnya syarikat sendiri. Dan semua ni adalah hasil daripada didikan ataupun program yang ditawarkan di MMU. Okay. Okay, saya rasa yang tu untuk tentang MMU. Okey, saya habiskan di sini untuk MMU punya. Jadi, okey. Selain daripada itu, kejap saya stop sharing. Okey. Okey. Okey, tadi kita dah tengok tentang MMU. Okey, saya ucapkan terima kasih kerana sudi mendengar apa yang telah kami bicarakan tadi. Okey, untuk maklumat lanjut, pelajar-pelajar boleh melihat ataupun melayari laman web MMU di www.mmu.edu.my. Okeylah, baiklah, sebelum kita mendengar tip dan nasihat dari penceramah kita, okey, mari kita kenal siapakah dia yang saya masukkan itu. Okey. Beliau yang saya masukkan di sini adalah Cikgu KHOO NGE Seng, merupakan guru akademik tingkatan 6 Sekolah Menengah Kebangsaan Munshi Abdullah Batu Berendam Melaka. Beliau mempunyai pengalaman mengajar dalam subjek Fizik STPM 18 tahun, guru subjek Fizik SPM 6 tahun dan beliau juga merupakan pemeriksa kertas Fizik STPM semester 1 dan semester 2 dan berpengalaman selama 10 tahun. Selain dari itu, beliau juga adalah jurulatih utama negeri kerja khusus bagi subjek STPM selama 4 tahun. Okey, dengan pengalaman yang sedia ada, pasti banyak tip dan nasihat akan diberikan. Saya harap pelajar-pelajar di luar sana sudah bersedia untuk mendengarnya. Okey, sebagai pembuka bicara, izinkan saya menyampaikan serangkap pantun. Pergi berkelah membawa ketupat. bawa bersama roti dan tikar. Hanya tunggu tip dan nasihat. Kami pelajar tak sabar menanti. Tanpa membuang waktu, saya menjemput Cikgu KHOO NGE SENG iaitu guru fizik untuk meneruskan seminar ini. Dipersilakan Cikgu.
Okey, terima kasih Cikgu Maizan.
Terima kasih Cikgu.
Yeah.
Apa khabar Cikgu?
Okay. Yeah. Okay, thank you. So, a very good afternoon to all the students. I'm Mr. KHOO from SMK Munshi Abdullah, MELAKA. So, today I'd like to share something or tips is about STPM examination, especially in physics subjects. Alright, so without further ado, we go to the presentation for today. So let me share the screen with you. Alright, so now we go to the answering techniques for this physics paper 2, which is code number 960/2. Of course, the format for the the exam paper, I think most of you know about the format. So I think it's a make of section A, which is consists of 15 multiple choice question. They want compulsory to answer all. And then section B will be the 2 structure question. That mean also compulsory to answer both questions. And section C consists of 3 essays. This one must be careful because 3 essay question, you only have to answer 2 questions. I repeat, this one you need to answer only 2 questions because normally the last question we will cancel the question. We will mark the last question, right? This is a procedure that we follow. So that means I always advise my student to answer section A or section B also or section C answer 2 questions only. Alright, and the time entitled for this SEM 2 paper will be 90 minutes or maybe 1 hour and 30 minutes. So the time that is advice given to you will be, they say the 15 objective, maybe you spend not more than 30 minutes, right? That means not more than 30 minutes for your multiple choice question. Okay, this one including the choices of A, B, C, D. So A is around 30 minutes, all right? Not more than 30 minutes. And then the structure question, because consists of 2 questions, you need to spend around 20 minutes, right? Average is 20 minutes. Then about the 2 essays, you can spend around 40 minutes. Okay, these are the common or we call the format time entitled for this paper, but of course, different students got different strategy to tackle the question. Some like to do the structure first, and then followed by essay, followed by the multiple choice question. Right? But my advice for you is, of course, we need to focus on the section B and section C rather than section A. Right? But I didn't say that section A not important, right? But the percentage of the section A in this paper is lesser compared to the B and C, right? So for me, if you can score in section B and C, of course, you will get a good marks upon the 60. But 60. The full mark is 60. It convert to 26.7%. Okay, so there's a format that we know. This one is like a SEM 1 also. Only the question is about electricity and magnetism. All right, okay, so now we go to the answering technique for this paper 2, all right, about this section B and C. You're talking about the section B and C, about the structure and also the essay. So question on the state a law. Example, you are given the question asks you about the state. Look at the word state, right? State the law, a principle, postulate, or hypothesis. So state normally is ask you example like state Newton's law, or state energy conservation law, or state the Bose postulate, right? A Bose postulate you will cover in SEM 3. So for example, this you see the word state, right? You need to, the answer required is a words and sentence, right? These are important, and it means you need to answer the question in words and sentence. So answer given in the mathematical form, that means you write the formula or equation, consider incomplete. Consider incomplete. That's why for the question require you state the law or state any energy or postulate hypothesis, you need to write is in sentences or words. Right? If you write formula, it define the symbol, you consider this is a wrong because it's considered incomplete. Okay, so remember, bear in mind that this one is a very we call is a very drastic technique. You need to master that when the question on state, you need to give the answer in terms of words and sentences. All right, state, word, and sentences. Okay, number 2 is about the question on state which carry the same meaning as a name and right. Normally, this is the mark given for this question normally is carry 1 marks. I mean, 1 mark is for this. It means you just state right now the name, right now the force. Or we call state the type of force. Example, the answer is a frictional force, right? So state the type of force means you want to require you to write the name of the force. So the force is example is a frictional force. Maybe they want given 1 mark, right? But state the phenomena. Example, the phenomena is a resonance. And state the equation. Example equation for this electromagnetic induction, we know the formula given by the EMF is equal to negative d phi dt. Okay, this equation will bring you the meaning of the electromagnetic induction, where this formula consists of 2 laws. One is about the Faraday law, one is about the Lenz's law. One is a Faraday's, one is a Lenz's law. So normally for this kind of question, only you write the name of this the phenomena. So require short answer in word or manual formula will be all symbol explained. So if you want to write the formula, you need to explain the symbol. Okay, so for me, better you write this one in terms of short answer in word, or I mean in a short phrase, right? Example, frictional force. Okay, and this is great. You look at the mark, even normally is 1 mark. Okay, number 3 is a question of state the different or distinguish. Normally is about ask about the difference between the 2 things. Example, state 3 differences between the progressive wave and the stationary wave. Okay, so normally for this kind of question, you can give in terms of the words and sentence. In terms of word and sentence, and then you are encouraged to do, you can answer this kind of question in a table. You can build a table like that. All right, you can build a table with a row and column. Okay, so example, the first one is for progressive wave. Progressive wave. Number 2 is for standing wave. Okay, then write the point 1. What is that? Okay, say progressive wave is always propagating forwards. And standing wave is not propagating forwards. That one is considered first different. Okay, because you can put in table form or you can put in the point form. All right, for this, so example, you can state the 3 differences between the progressive wave and the stationary wave, distinguish between the sound wave and EM wave, distinguish between the DC and AC. Example for this M2, you're talking about the DC and also AC, right? So you try to differentiate between these two currents by using the table, and then you try to write out the difference between them. Right? The DC normally is considered the value or mid direction is only a 1 direction, whereas for AC, the current flow in alternate direction. So there's a difference between the DC and AC. Okay, so there's a that kind of question about that will come out in your appear in your section B or section C. Okay, question about number 4. question of definition. Normally they ask you about the define magnetic flux density, define molar heat capacity, define atomic mass unit, and define simple harmonic motion. So for the define here, it can be either. So on definition, normally you are required to write the answer in words or sentence, or can be mathematical formula. But don't forget you need to explain all the symbol. Okay, it's a different from state question. So back to number 1 about the state law, right? So state the law is encouraged to write in terms of words or sentence. Okay, you write the formula and explain the symbol is considered incomplete, right? But for define it can be word and sentence plus mathematical formula, or can be max formula with all the symbol explained. I mean, definition is more lenient, and it can be word or sentence, and also can be formula with the explanation. But state must be words and sentence. Okay, this one you read the question carefully. It's about what kind of question asked in the structure in the essay question. Okay, number 5 is about what is meant by this. What is meant by this means, example, what is meant by momentum, what is meant by critical damping. Is it now? So that means from here, it give you require you to give the effect, right? Momentum is about you can say momentum is about the product of mass and velocity. Okay, it's about the critical damping. You must explain the phenomena or maybe the effect of critical damping. You can see the for critical damping, normally we can say oscillation doesn't happen even one, right? Something like that is called the effect. There's a structural question can be what is meant by this. You need to focus on the effects. Okay, number 6, question on the describe or illustrate. That means describe the mechanism of heat conduction, describe the fission process. So mechanism of heat conduction, this one we already studied in Sem 1. About the heat conduction, when temperature increases, we can see the atom vibrate more vigorously. Then the heat transfer from the first atom go to the neighboring atom. All right. Then this one heat transfer, we need to tell the teacher that how the thing is going on. So this is like a storytelling. All right. You need to tell, to describe how the process is going on or how the mechanism is going on. So this is called describe, or we call illustrate. Right? It's like a storytelling. Okay, so there's a question number 6. Then maybe number 7 is about explain, and then it asks why or how. Example, explain why the particle move with constant speed in the circle has an acceleration. Alright, this is the one that we done in Sem 1 under circular motion. We found that when a particle moves in the circular motion, even though with the constant speed, we have a change in velocity. Even though with the constant speed in the circle, you're having the constant speed by having different velocity, because the particle is having changing in direction. Alright, as long as there's a change in velocity, you're having acceleration. Okay, so this acceleration will always acting towards the center. So this particular acceleration is called centripetal acceleration. So because of this acceleration will produce, you will make the resultant force will become the acceleration will produce with the circular centripetal force. Alright, this is one example that we learned in Sem 1. Explain the object move and how to break a nucleus. So this one also can be a required answer in word and sentence. Normally they ask in terms of word and sentence. Alright, you can use, may use mathematical analysis of graph, must include the effect and the causes. So normally for this kind of question, you can draw a diagram, maybe this graph to enhance your answer. Example for this particle move in a constant speed, having acceleration, we can explain by using the change in velocity. Alright, you can see the delta V is equal to your V2 minus V1. Alright, from here you can explain about when there's a change of velocity, there's a change of there's acceleration. That's why there's a resultant force. Okay. And then number 8 is about the calculation, or we call determine. All right. So calculation is example, calculate the final velocity, determine the direction of impact. Impact is either opposite direction or same direction. So this one require mainly mathematical analysis. So for this calculation question, it's important to be taken care. So calculation or determination of the value start from the basic formula of physics relation, right? Always start with the formula. Always start with the basic formula. Example, the basic formula for our Coulomb's law is equal to F, right? F is equal to Q1, Q2 by 4 pi epsilon naught R squared. So that is called the basic formula or Newton's law, right? F equal to ma and so on. After you write the formula, you need to substitute the values into the formula. Alright, okay, substitution of the formula, I mean the value into the formula. That don't forget to convert into SI base unit. What I mean by the SI base unit? SI base unit including your kg. Sometimes the question given is a gram. You need to convert to kg. Is it not? Right? Example, you're given the unit, the mass is a gram. You convert to kg. Sometimes diameter given is a millimeter. You need to convert to meter. Right? So the kilogram, the meter, and so on, that one is considered your SI base units. Okay? There's the one you need to take care of, because the final answer must in terms of the base units. I mean the overall is a derivation of the base unit. Okay, but do not include the unit in the intermediate step. So when you do the calculation at the center, right, at the intermediate step, we no need to write the unit. Unit is required at the final answer. Again, unit is required in the final answer. Okay, so first one, use the formula, substitute with correct base unit. Number 3, no rounding off or value in the intermediate step. No rounding off means the value, you don't make it too less significant. Example, the answer you calculate, intermediate answer is 48.234. Is it not? This one is 5 significant. It's okay. Right? This one intermediate because it never reach a final answer. So 48.234, it don't round off to 48.2. Because finally, this one will affect your final answer. If you round to 48.2, your final answer is different from the student will use the 48.234. Right? Of course, the 48.234 is more accurate than 48.2. Is it not? So that means in the intermediate answer, you can use more significant. It can up to 4 or 5 significant. Okay, only substitute into the formula to get the final answer. This is the final answer is if I use the 48.234, maybe the answer is a 56.4. If you use a 48.2, your answer maybe get 56.3. Alright, so that means if you use the first one, 48.234 as an intermediate, final answer is a 56.4 is correct. If you take 48.2, final answer 50.3 is wrong. That's why I lost a mark in final answer. Okay, so remember, when you round off the value in the intermediate, don't round off too early. So this is called early round off. So this error we call early round off. Okay, you must make a habit that don't do early round off, because this one will make your answer not accurate in the final answer. Okay, so this one no rounding off. So you highlight the important facts here. No rounding off the value. Okay, number 4, final answer must be the units, and that means must be correct unit. Is that all? So final answer must be correct unit. That's the one we emphasize. And then number 5, the value of the final answer must be written to the numbers of significant features of the data. Data means the primary data, right? So that means you got according to the data. If the given data is a mixture of significant, example in your calculation, you are given the data is 2.0. use a pen to write. Example, teacher value the y, okay, the y equal to 2.0 multiplied by 3.00 multiplied by 4.000. Okay, so that means you can see from here, 2.0 consider 2 significant figure, 3.00 consider 3 significant figure, 4.000 consider 4 significant figure, right? So that means we follow the least one. The least one, the least one should be 2 significant figure. Alright, that means you got 2 times 3 is a 6 times 4 become 24 lah. So accept 24. Consider 2 significant, or can be 1 extra. Can be 3 significant. Alright, this one cannot. That means you follow the least number. You got 2 significant, you got 3 significant, we got 4 significant. You follow the least one, we follow 2 significant figure in our final answer. Okay, so that one is a number significant. So that means in this calculation, you follow the procedure here. You start with the formula, substitute the value after the SI base unit, no rounding off a value, then got the unit, and somehow write to the correct significant figure. Okay, the last one about the graph. No, sometimes they ask you to sketch a graph about the X-ray spectrum graph, about the IV graph, about the X-ray graph. Sometimes you sketch like this. Is about the intensity against the lambda, right? So the graph maybe is starting with this, and then got 2 peak here, right? This one later we learn in Sem 3. So normally for this graph, we need to label. This is for intensity against the lambda, which is a wavelength, right? So must label when you're given the question about sketch a graph, you need to label. Alright, origin to be indicated with 0. So there's origin, you must label 0 here. Or label 0. And then sometimes you need to put in some special figure. Example, you are given like a force on the current carrying conductor. The F equal to BIL. Yeah, sine theta. Right? So you can see maybe the graph is a sine graph, yes or not? It's a sine graph. Then you can see this one is a force. So against a theta. Right? I need to write origin here, 0. So in our post here, this one must be 90 degrees. So when this is a 90 degrees, you get the answer is a maximum force will equal to BIL. Alright? So this one you must label here. This value given by BIL. This is called the special number there. There is a maximum force. And the magnetic force on the conductor. Okay, so this is about the graph in our structure and also the essay. Hopefully the tips on this will help the student to understand more how to tackle the question in the exam and try to avoid the errors, especially in the calculation errors. But basically for this script, I mean the answer from the student, normally you found that student is okay, they are okay in the calculation question. We call quantitative question, but not so good in the qualitative question. So quantity means calculation. So that means student can memorize the formula very well, perform the good calculation, can get the full mark. But they are weak in qualitative question. Qualitative means explanation, describe. That's the winners of the candidate for physics. Okay. All right. Hopefully this one will help you to improve your grade in your exam. I mean the coming exam in your real one will be September. Okay. So that one is answering technique in our seminar for today. All right. Okay. Now we go to the next slide. Is about the syllabus. So today actually teacher want to do revision with you. I mean, together we go through the STPM syllabus, Sem 2. So that means we need to have like we do a checklist, So checklist to state that which skill you need to master, and then which one you need to be careful. So let's say this one is not so familiar. You try to go through it in the text, and then you get a better understanding with the law. Right? So this is the purpose teacher do the revision section with you with this syllabus in our SEM 2. So it's about electricity and magnetism. So we know, as you know, this SEM 2 consists of 7 chapters, yes or no? So the first chapter will be electrostatic. Yeah, so first of all, we look at the skill into you need to master. The skill is about the state the Gauss Coulomb's law, yes or no? So candidates should be able to state the Coulomb's law and use a formula. So what is the Coulomb's law that we know? Yes, so this one you see the word state. So can you write the formula or not? State. So just now I told you about the answering technique. State, you cannot use a formula. We cannot use a formula. State must be in words or sentence. Yes or no? So Coulomb's law given by, you mean hopefully when the student attending this seminar, so we need to work together. When teacher write something or maybe read out some sentences, you try to copy down or maybe jot some, make some important notes in your handout. All right, this is a purpose doing revision. So we do revision together for this M2. All right, so the common Coulomb's law definition given by electrostatic force between two charges. All right, electrostatic force between two charges is directly proportional to the product of the charges and inversely proportional to the square of the separation. All right, so that means you must mention about electrostatic force between two charges is directly proportional to the product of the charges and inversely proportional to the square of the separation. So that means in terms of relationship, the force between two charges is equal to, you can say proportional to what? Is proportional to Q1 multiplied by Q2. Alright, then divided by R squared. R considered is a common symbol for separation. Okay, this one is called the Coulomb's law. Remember, this one must write in sentence. Okay, then use the formula F is a QQ by 4 pi epsilon R square. So this is a normal formula for Coulomb's law. So please highlight the formula here. This is a formula you need to memorize to solve the calculation question. Okay, skill B, explain the meaning of electric field and sketch a few patterns for isolated point charges, electric dipole and uniform charge sphere. Example, electric field given here, because electric field actually is not a quantity. Electric field strength is a quantity, yeah? Electric field strength considered is a force per unit charge. But electric field actually is a region, is an area, is a region where a charge experience electrostatic force. Again, electric field means is an area or region where a charge experience electrostatic force. So that's called electric field. Alright, so in this session, the question B, you need to know the field pattern for isolated point charge. Example, you are given this is a point charge, right? Maybe it's a positive charge. You need to know what is the field pattern for this electric field. So we know that means the line should be like that. This is all the imaginary line that we describe. This is for the electric field. Then we know that electric field is acting out for positive, in for negative. Yes or no? So that means for positive charge is a positive out, negative will be acting in. Right? I can see the line will produce consider your electric field pattern. Okay, so this one can be referred to the text about the dipole and uniform charge sphere lah. Right, there is a skill. That's why when you go through the syllabus, at least you get a rough idea that what kind of question that normally will be asked in the question. But I cannot guarantee that the question come up. But you need to master all the skill in the syllabus. This is very important, or we call this is a fundamental. Okay, C, define the electric field strength. Electric field strength given by, the definition is given by force per unit positive charge. Alright, electric field strength is E, so this is called define. When you see the word define, can we use a formula or not? Yes, it can use a formula, it can use a words or sentence. So normally you can use a sentence to say that electric field strength is given by force per unit positive charge. Okay, or you can write the formula there, E equal to F per Q, then define the symbol. Every time you write the formula for definition, don't forget to define the symbol. Define the E. E for what? E for electric field strength. F is for force. The Q for unit charge, or we call unit positive charge. Okay, so that one is a formula for electric field strength. We highlight the formula. E equal to force over Q. There you can see the F actually equal to what? The F equal to QE. Right? There's a formula for you try to relate the electric force and the electric field strength. Okay, then D, describe the motion of the point charge in the uniform electric field. Example, you are given a point charge. Example, you are given that one is your uniform electric field. This one is a positive plate. So this is your negative plate. Of course, you want to sketch the electric field is acting from positive to negative. This one is called your uniform electric field. So once there's an electron enter from the left-hand side. Example, there's electron enter. Of course, the electron will be attracted to positive plate. So this one perform the parabolic path. Okay, so this path is called parabolic path. All right, okay, see from here because it's acting by the electrostatic force. So the thing will go to positive plate because of the force acting on this. Normally, the question we ignore the gravity because consider gravity effect on the charge is very small since the mass of electron is very, very small. Okay, so you need to describe. See that? In the skill, they ask you to describe. They mean need to tell the story, how the thing going on, why the electron is having this kind of path because of force and the force and direction of this electric field. Okay, is described. Okay, then number E is about state the Gauss law and apply to derive the electric field strength for isolated point charge, isolated charge conducting sphere, and uniform charge plate. So this is called Gauss law. State the Gauss law, you must mention in terms of the word or sentence. So Gauss law, if we look at the formula, right? Formula for Gauss law is equal to, normally you write either your epsilon naught phi will equal to the summation of the Q. Right? So this one is given by where the epsilon naught is called the permittivity of the free space or vacuum. This is called electric flux. Electric flux will equal to the E multiplied by A. Actually, it's an integral form. We just consider as a EA. Then this is a summation of the charge enclosed in the Gaussian surface. Alright, then the phi will equal to the summation of Q over epsilon naught. Yes, so you want to state the Gauss law. From here you can say, actually Gauss law can be said electric flux through a Gaussian surface. Yes, from here, because you need to write in sentence, right? Electric flux through a Gaussian surface is directly proportional to the total charge enclosed in the surface or by the surface. Again, electric flux through a Gaussian surface is directly proportional to the total charge, or we call to the total charge enclosed by the surface. Alright, this is called the Gauss law and apply it. So we use the Gauss law to prove what is the electric field strength. So the purpose of Gauss law is to prove this electric field strength. Example, if I prove, example, you are given this is a plate. The plate having the electric field at one side, right? This one consider is electric field is a non-isolated is here. So that means you want to find the electric field strength of this charge plate. We need to put we need to build the Gaussian surface. So where the Gaussian surface is a uniform cylinder, right? The cylinder is here. Okay, so that means from here you want to find the electric field at here. you must use epsilon naught phi. The phi equal to EA. So only the third area is affected by the electric flux. So that means this is a EA equal to, they say the charge enclosed by the surface is a Q. So equal to the Q. So finally the E become the Q over epsilon naught A lah. Right? This one become the E will equal to the sigma over epsilon naught. So the sigma is called your charge density, right? So sigma is a charge density or equal to Q per A. Okay, so that is a normal derivation of this Gauss law for the charge plate. It can be used for point charge. Example for point charge, electric field or point charge is equal to Q by 4 pi epsilon naught R squared. Okay, so point charge is 4 pi epsilon R squared. Electric, this is a charge sphere, also the same formula, right? It's a Q by 4 pi epsilon naught R squared. But mind you, in the charge sphere, normally the charge inside the sphere considered 0 because the charge will be stay at the surface. At the surface, so the charge is a 0 here. So that means at the center, the electric field should be 0. Yeah, only at the side there is where I can see the curve for this electric field against the distance will be something like this. This one is the center, is a 0 electric field against R. So at the radius there, I can see the thing become a curve, because proportional to 1 over R squared. Okay, this one is the left hand side also the same. Okay, so this is a Gauss law that you need to take note how to derive to get the electric field. Okay, then we go to the skill F, define electric potential. So define, of course, you can use a formula or maybe the word to explain. Electric potential normally is a work done. Is a work done to bring a unit positive charge from infinity to a point. Yeah, it's a work done to bring a unit positive charge from infinity to a point. So it's called electric potential, right? So the symbol for potential is a V. So the formula given to you, the V equal to Q by 4 pi epsilon R. Yes, so this is called define electric potential. Alright, okay, explain the meaning of equal potential surfaces. So equal potential surfaces is meant by when you transfer a charge between the equal potential surfaces, there is no work done. It's called equal potential surfaces. Example, if we sketch a pattern for equal potential surfaces, be something like this. Right? Example, this one is your sphere, carry charge. So that means this one is your electric field. Alright, so that means you want to draw the equal potential surfaces. Maybe this is a number 1. The blue color is the first surface. Right? And this is called the surface number 1, followed by surface number 2, and so on. Around the source. So that means if you look at the surface number 1, if you transfer a charge in between surface number 1, example, transfer from point A to point B at the same surface, or A at the surface number 1, B also at the surface number 1, we consider the work done is a 0 because there is no potential difference. That's why they call equal potential. They're having same potential, right? But you transfer the point A to point C, the point C is at the second surface. This is considered there is a potential difference. That's why there's a work done. You transfer the charge A to C. Okay? Alright. Okay, the one is equal potential surfaces. Then this one is use the relationship. E is a minus dVdr. This one normally you can use in the graph to analyze the answer from here. The E is a minus dVdr. And then use the formula U equal to QV. Right? So mind you, the U stands for electric potential energy. The V stands for electric potential. Okay? The U is considered electric potential energy. The V stands for electric potential. So these are the important formula and the concept we need to know when you master the first topic for electrostatic. Alright, okay, this is the first topic. Then we go to the question for this because we try to go through certain question in your past year. Okay, so this one we do the question for electrostatic. Example, teacher prepare this question for you. Yes. Section B and C lah. Alright. So you can see how many questions can be done because of the time limited. So let me I just show you the way or the tips to do revision on your own, because the most important thing is you need to do revision on your own. I said right, you need to do revision. So for me, you need to have during revision you need to jot down certain important thing and try to derive the formula by yourself and try to memorize the important formula, right? So to enhance or to upgrade your result. Okay, now we go to question number 1 about this electrostatic. Okay, so 2-point charges is given by -30 microcoulomb and 60 microcoulomb separated by distance 14 cm as shown in the diagram below. So X located 2 cm from the negative charge. Alright, the calculate the force between two charges. So this is a very common question because you are given one negative, one positive. So mind you, in the calculation for force, we can ignore the negative. And we know this is actually the attractive force. Because one is a negative, one is a positive, right? So this is an attractive force. So we can ignore the negative by taking the magnitude only, right? So this one is a force acting between the -30 and 60 microcoulomb. So everything start with the formula F equal to Q1 Q2 by 4 pi epsilon naught R squared. Okay, so this one is one of the, we start with the basic formula. Is that right? We start with the basic formula. After that, we substitute value. So value number 1 is 30 microcoulomb, 30.0 microcoulomb multiplied by 60.0 microcoulomb divided by 4 pi. The epsilon naught, you can use a value from the constant at the back, because normally at the end of the page, you got one constant list. It's advised to use a constant list in the exam paper. Alright, or some students use a calculator. We consider also, but the most accurate, you can use a constant list in the exam paper. So the epsilon naught is given by 8.85 times 10 to the power -12. So multiply by the distance is how many? 14 cm. So remember the cm is not the SI base unit. So remember the cm need to convert to meter. This is a very common mistake done by the student. You never convert the cm become meter. So the answer will be wrong. Alright, so you write the 0.14 is for 14 cm. So after you do the calculation here, the answer I give you, of course, you need to do the correct calculation. Be careful when you use your calculator to calculate. Alright, then there's a square here. Yes or no? There's a square here. So because of the Q1, Q2 by 4 pi epsilon R squared, so the answer you get is 825.8 Newton. Okay, so this one is, look at the final answer, it go to, actually this one can be the false significant. Alright, so according to here, actually the value given inside the data is 14.0. Actually this one is a 0.140 according to the data given. Or according to the question given, you can see this one considered 3 significant. This also 3 significant. So this also considered 3 significant. Yes or no? Even 8.85 also considered 3 significant. So minimum can be 3 significant. You follow the list, it can be 826 Newton. Or can be 1 extra significant. It can be 3 significant or 4 significant. So that means after calculation, when you do the final answer, you try to look at the data. So these are called all the data, all the data. So looking the primary data there to finalize what is significant, you need to write in the final answer. Yeah, okay. Example, this one, the significant is a 2, right? I follow the 2, minimum 2, it can be 3. Alright, this is the data that we need. So for this significant is a 3, you can write 3 or 4. Okay, yes. So this one, the first part is formula with the substitute and the answer. Okay, number B, determine the magnetic direction of the resultant electric field at the X. So now look at the point X here. Every time you want to find the electric field, I think you need to put a test charge. The test charge must be positive. Correct? So there's a learn there. Because you want to know the electric field direction or value, we need to test whether the direction is correct or not. So normally you put the positive charge here at the point X. Okay, so now we compare the direction between the minus 30 and the positive charge. So this one should be attractive, yes or no? It's attractive, so that means the direction of electric field is going to the left. So this is called E1, between the negative 30 and the positive charge. So this one is considered the small q, positive q. So this is called your test charge. So remember, to find electric field strength, remember, need to put the test charge. Electric force, no need. Electric field strength, you need to put the test charge. And then for the second charge is a 60 microcoulomb, and the positive is a repel, right? Repel. So that means we go to the other side. So this one is considered repel, is also go to the left. Is it not? So E1, E2 is having the same direction. So same direction means we need to add up together. In opposite direction, we need to minus, right, the electric field. So now for this magnetic of the magnetic resultant electric field, you can use the electric field formula equal to Q by 4 pi epsilon naught R squared. Okay, for this, also don't need to care about, no need to consider the negative, we just take the magnitude. Only when do potential, we need to consider the negative. If the charge is negative, potential becomes negative. If the charge is positive, the potential becomes positive. Okay, so for electric force, electric field, the sign of the charge can be ignored. We just take the value. Understand? So for these two, I can calculate the value. The Q1 is for minus 30, right? So that means the Q1, you can use E1 and E2 . E1 is between the minus 30 and also the positive. So that means this one become Q is equal to 30 microcoulomb divided by 4 pi epsilon naught 8.85 minus 12 divided by the distance is 2 meter 0.020. Then you square it. That one is your E1. Alright. E2 is between the 60 microcoulomb and the point charge. So 4 pi 8.85 to the power negative 12. So the distance from the 60 to the X will be considered 12 cm. That's right. Where this is a 12 cm, their side is a 2 cm. Total is a 14. So finally become 12 cm will be 0.12 square. Okay, so there is answer for E1, E2. So you press in your calculator, you got the final answer will be 7.119 to the power 8. Yes, rewrite the unit for electric field. It must be Newton per coulomb. Or sometimes teacher say volt per meter. Yeah, it can be this or that. Alright, so this one, because you are given 4 marks, don't forget to read the question carefully. They ask about magnitude and direction. Yes or no? We need to see the direction of the resultant electric field. So magnitude already calculated, done. Alright, so that means for the direction, it must mention where. So you say its direction is towards where? Is go to the left, yes or no? According to the diagram, is go to the left, or you can say the direction is towards the direction towards negative 30 microcoulomb charge. Okay, it's going left, or I can say going to the left. Alright, okay, there is a standard calculation for this formula. Substitute, answer with correct unit, then don't forget the direction. Okay, C, predict a possible position of point where the resultant field is 0. So for this case, the resultant field 0. You can see the point, you want to test whether can get resultant force field 0 or not. So we come back to this question. We try to analyze which is a point that we can get resultant force 0. Right? Example, the first one, this one you put at the left hand side. You say teacher put the positive charge here, yes or no? So put a positive charge here, positive and negative, consider this is attractive force. So this one become your E1. Between the positive and minus 60 is considered repulsive. So that one is your E2. Okay, so you look at this, E1 is going to the right, E2 going to the left. So the E1 value, because the charge is small, the distance shorter. Compared to the E2, the charge is big, but the distance is longer. So that means E1, the charge is small, the distance shorter. Then the E2 is the charge is big, the distance longer. So that means the E1, E2 can be equal. So this is the first position that we know. Right, second position is at the center. Let's say we try here. So of course, just now we try already, of course, right? At the center, the electric field is always go to the left. Yes or no? So at the center cannot, and because cannot get 0. So you try at the right hand side there, you put the positive charge here. Yeah. So you try to compare positive and 60 microcoulomb consider repulsive. Repulsive means the electric field is going to the right. Right? Then between the positive and the minus 30 is attractive, it's going to the left. Right? But the problem is when you see the 60 microcoulomb is a big charge, the distance is shorter. Of course, the force is big, electric field also big. I said right? E2 is between the minus 30 to the positive. The charge is small. Some more distance is longer. So the value cannot equal to E2. I mean E1 would not equal to E2. So not equal to E2, of course, answer cannot be 0. Yes, so center not 0, right also not 0. So the answer is on the left. So that means you write the answer from here. What is a possible position? Is it 1 point? Yeah, 1 point on the left. Okay, of the negative charge. Okay, 1 point on the left of negative charge. So this is a possible position of the point. That means including this question, you can see total is 7 marks. You can see that from there, your calculation already taken you around 6 marks. So the last one will be the position that we know. Okay, this is a randomly teacher choose one question from there. No? So the rest, of course, you need to keep on doing the question and go through the past question. All right, then you found that, yeah, there's a pattern, or maybe you can get a very good understanding about answering skill. All right, this will help you a lot. So please do more revision. Yes, okay, that one is question number 1 for topic number 1. Okay, now go to number 2 is about capacitor. All right, so of course I think cannot finish by today. So maybe you see how many topics we can finish. After that, with the rest you need to your teacher already showed the way how you do, right? If cannot finish by today, so maybe you can go back to school. You can do your own revision, right? By referring the method that I show you for today. Okay, because this one the syllabus, of course, you need to go through, and then of course need to get a deep understanding of the theory. Okay, now go to the second topic for SEM 2 is about capacitor. So define capacitance, also define it can be the formula or can be the sentence. Yes or no? Define. So formula for capacitance we know C equal to Q per V. Alright? C equal to Q per V. Alright, so that means from here you can see lah. So the capacitance is actually the ratio of charge on each plate of the capacitor to the potential difference between the plates. Again, is the ratio of the charge stored on each plate of the capacitor to the potential difference between the plate. So that is called your capacitance. You can write the formula, you can write the formula, define the symbol. Example, C for capacitance, Q for charge stored on each plate of the capacitor. What is the V? The V stands for potential difference. Okay, because of the word define, you can write in sentence or you can write in formula by explaining the symbol. Okay, B, describe the mechanism of charging a parallel plate capacitor. So describe the mechanism of charging parallel plate capacitor. So see the word describe or not. Describe means you need to tell story. What the mechanism? Example, you are given this is a charge capacitor. Alright, this is a capacitor. Then this one is a battery. Okay, battery, this is a positive, this is a negative. So of course, when you on the switch, of course, the electron from the negative terminal will go to the plate at the right hand side. Alright, so finally, the right hand side will become negative charge because the electron charge up this positive side. After that, the right hand side. After that, the second plate will induce become positive charge. Okay, so now the right hand side become negative charge, left hand side become positive charge. This one will build a potential difference. Okay, so when the potential difference is equal to the battery potential difference of voltage, so now the capacitor considered fully charged. Example, the voltage is a 12 volt, is it not? So starting capacitor considered 0 volt. Until the capacitor also 12 volt, then the process consider finish. The capacitor consider fully charged. Okay, so describe need to tell the story. Normally, this one in the exam will give you 3 to 4 marks, something like that, right? This is a mechanism. Okay, then C, use a formula C equal to Q per V to derive the formula C equal to epsilon naught A per D. Alright, so this one need to derive from this formula C equal to Q per V to get this formula in terms of the epsilon naught A per D. Alright, so that means from here we can say that electric field on the charge parallel capacitor E equal to sigma by epsilon naught. So what is a sigma? Sigma stands for charge density, is a Q per A epsilon naught. Then also we know electric field given by voltage over separation. Yes or no? So that means you just use your electric field, the Q over A epsilon naught, will equal to V per D. So finally, the Q per V will equal to epsilon naught A per D. Alright, so what is your Q per V? So they one stand for your capacitance. So capacitance given by epsilon naught A per D lah. So provided the medium between them is a vacuum, So this is an air-filled capacitor. We call air-filled. Air-filled means the medium between them is air or considered vacuum. Vacuum, the permittivity given by epsilon naught. Or we call epsilon 0 lah, right? So this is how we derive the formula for capacitance. Okay, next we go to the define relative permittivity epsilon R. So epsilon R means dielectric constant, or we call relative permittivity. Epsilon R, normally the definition for this is called, you can use a define, of course can use a symbol. So epsilon R can equal to epsilon over epsilon naught. Yeah, so what is epsilon stand for? So this is a permittivity of the material. Is a permittivity of the material. Epsilon naught is a permittivity of the free space or vacuum. This one can become definition. You want to write in the sentence also okay. It's a ratio of permittivity of the material to permittivity of the free space. Okay, that's called epsilon R. Alright, okay, this one is define. After that, describe the effect of dielectric in the parallel plate capacitor. So this is a very popular question. You look at the past year, they like you to describe, storytelling why the dielectric can cause effect on the capacitance. So of course, without the dielectric, initially, you can see from here now, so this is a positive negative lah. Original capacitor without dielectric, you got electric field is acting from the left to the right. So let's say this one called E1. Okay, so after insert dielectric in between the plates, all right, so this dielectric will perform the process we call polarization. The word is called polarization. Occurs. When this one occurs, we are having the electric dipole. Electric dipole means the dielectric will perform the charge nearby the positive one will become negative charge. And the side nearby the negative one become positive charge. Okay, so that means now the dielectric inside, the charge induced, here is a plus, this side become negative. So that means they induce another electric field, we call E2. E2 is opposite to E1. So E1 is going to the right, E2 going to the left. So finally, your resultant electric field will decrease. Yes or no? So when electric field decrease, for this question, the charge is conserved, or we call the charge is constant. Alright, okay, electric field decrease means the voltage also decrease. Yeah, because E equal to V per D, the D unchanged. So now when the V becomes smaller, E also becomes smaller. So from the formula C equal to Q per V, right? Charge is conserved. So that means when the V becomes smaller, the C becomes bigger. So that's why what is the function of the dielectric? It must use to increase capacitance. Okay, this is a process. I mean like storytelling, right? It must get like that to get the 4 marks for this question example. Alright. So use the formula C equals epsilon R epsilon naught A per D. What is the formula for this? When you put the dielectric inside, so the formula becomes C equal to what? The C must equal to epsilon A per D. Epsilon, epsilon means the permittivity of the material. Epsilon will equal to what? Epsilon will equal to epsilon R multiplied by epsilon naught. You must get the relationship very clear. A lot of students confused about relationship. Don't know who divide by who. Right? And this is a thing that you need to be careful. So when the thing is the material main capacitor with the dielectric inside, we just write C with epsilon A per D. Without the dielectric is epsilon naught A per D. Okay, so that was capacitance. Okay, G, derive and use the formula for effective capacitor for parallel in series. This one should be simple. So for this series one, we know we want to find the capacitor is simple. You must use a 1 per C equal to 1 per C1 plus 1 per C2. Example, you got 2 capacitor. Right? I can find the C. And the C must equal to 1 per C1 plus 1 per C2 power minus 1. Because for series, of course, the charge flow is the same. Only different by potential different. So series, remember, charge flow is the same, but got different voltage in the capacitor. This is for series, yes or no? Then for parallel, what is the same? For parallel, it must be the voltage is the same, but the charge is different. So it's like for parallel capacitor, it must use the formula is C equal to C1 plus C2. Right? And this is the effective capacitor for parallel. This is the effective capacitor for series. If you look at the formula, this one is the reverse with the resistance. No? Remember, if for resistance, for series is R1 plus R2. For parallel is 1 per R equal to 1 per R1 plus 1 per R2. Okay, yes, the one is for series and the parallel mean capacitance. Now for use, this one use a formula, then we need to do calculation. Energy stored in the capacitor can be 1 per 2 QV. This one need to remember 1 per 2 Q square per C or 1 per 2 CV square. Right, these three formula actually is the same, but depends on the question. Normally, you can see the question say when the battery is still connected. When the battery is still connected, means the voltage remain the same. That's why you need to calculate energy using 1/2 CV squared. Example, the battery is still connected, you must make sure the V is constant. So to find the energy, use 1/2 CV squared. Right? Okay, the question says battery remove. Battery remove mean the charge is constant. So to find the energy stored, you can use a 1/2 Q squared per C. Because after remove the battery already, the V become different. The V no more the same. Yeah? So derivation are not required. You no need to rewrite. Just know how to use will do. No need to rewrite the formula for energy. Okay, then after this, I describe the charging and discharging process of capacitor used through a resistor. So this is a charging or discharging process about how the capacitor fully charged and so on. Okay, define the time constant. What is a time constant? Time constant is called the tau. Remember? The tau is a time taken for the capacitor to reduce to 1 per E of the initial charge. Time taken for the charge of capacitor to reduce to 1/E of the initial charge is called time constant. So formula for time constant equal to what? Equal to RC. RC, R for resistance, C for capacitance. Alright, okay, after that need to derive. You see the skill got derive, that means you need to practice a formula now. How to get the formula for this discharge. This is a charging capacitor. Right? For charging capacitor, if you look at the past year, this one come out before, yes, recently. It come out in 2022 U2. Right? About charging in capacitor. So the formula for Q is a Q naught, 1 minus E negative T over tau. The tau stands for CR, or we call time constant. So that is the first one for Q increases. If you sketch a graph for Q for charging process, you'll be something like this. Example, this one is your Q against T, right? So the graph should be a exponent graph. Then this one become your Q naught. Right? Q naught will be the maximum charge. Then the V also the same, same formula but different quantity. The voltage also increase exponentially. I mean the V also become increase, follow the pattern of exponent. So like that. This one become your EMF, or we call V naught. Okay, only the current would decrease for charging. Because for this current decrease, after you charge up the capacitor, the current should decrease because the potential difference already between capacitor and the battery becomes smaller. Because that's what we say when the thing already fully charged, so the current stop flowing. Yes or not? So one they got different in the reduced potential different, the current flow become very small. So the current graph for charging process is a decreasing graph now. The graph is like that, decreasing. Okay? So this is I know. So this figure is for charging one, for charging capacitor. Charging capacitor. So the formula given here. Alright, and then for this, derive the formula for discharging process. So discharging process and charging process, how to differentiate? You look at the circuit. When there's a battery given to you, consider charging. When no battery given to you, only through a resistor or load, so consider discharging. So discharging process, you got three formula. One is a Q decreasing, the V decreasing, the I also decreasing. Alright, so very easy to remember. So for discharging one, you can see all the three quantity decreasing exponentially. So this is a 1, so this is a 2, and then this is a 3. So all the three quantity decreases exponentially. So this is called your discharging process of a capacitor. Discharging process of capacitor, okay? And then after that, you need to solve problem. Yeah, this one must use exercise to do lah. And during exercise, so normally the exercise that teacher give to you in the school, please revise again. All right. Of course, when you do at the moment, maybe you can do. but after a certain moment you forget, yes or no? When you forget, that means you need to revise. Go through the question again. And this one is called revision. It's better than you go through the new question without you never revise the old question. Old question done already. Maybe understand at the moment, but now you forget. Yes or no? You try to recall. Okay, so solve problem, that means you need to go through exercise. Alright, okay, now go to the question for this capacitor. Yeah, there's one capacitor question here. Yeah, so just how we do. Yeah, we go to question 17 about capacitor, also structure. Alright, so for this one, I can see a capacitor. Capacitance 10 microfarad is initially charged by the battery. Potential difference 500 volt. A, determine the charge in the capacitor. So this is a calculation question we call quantitative question. We start with the basic formula. So Q equal to CV, yes or no? CV, so write the formula first. Q equal to CV. Then after that, substitute the value. C for capacitance, 10 micro times 500. Yes, so the answer given should be, you follow 2 significant, minimum 2 significant, can be 2 significant or 3 significant. So can be the answer 5.0 to the power minus 3 coulomb. There's a charge. Okay, this one very simple, right? Okay, B, the battery then removed and the capacitor is connected to uncharged capacitor of 40 microfarad. So when the battery removed, what is a constant? Just like I mentioned, right, in the battery removed, the charge is constant. The charge is constant. When the battery is still connected, the voltage is constant. Alright, so now we just put the value here. The charge conservation, your initial charge Q equal to final charge Q1 plus Q2. Yeah, so you can see the initial charge given by this. You follow the answer from part A. So 5.0 power minus 3 equal to, so Q1 finally is a C1V plus a C2V. So now you have to find the potential difference. That means these two is connect in parallel. Parallel only got the same potential difference. Only the charge will flow, right? So we just take out the voltage. Is a V multiplied by C1 plus C2. So you get the answer here will be equal to 100 volts. Yeah, so that is the final answer. Okay, so that one is, so you see the method I use normally, you start with formula, substitute, and then you convert unit. The micro must convert unit correctly. Even 10 micro need to convert. Some students write 10 only. You forget about the micro, So this is called preface, right? Preface also is important. Don't make careless mistake. Okay, number 2, calculate the total energy of both capacitor. So now for this, we know the capacitance is given by C1 plus C2. Then you want to know the voltage is 100. You can use the formula 1/2 CV squared. The C will be the total. Total is how many? 10 plus 40 become 50. 50 micro multiplied by 100 square. Yeah, they'll become your 1/2 CV squared. So now check the answer for this. 50 micro divided by 2 times 100 squared. So the answer is 0.25. Yes or not? 0.25 energy should be joule, right? Okay, so that is how you get a mark from these 2 marks. Okay, number 3, see the system of capacitor is then connect to the resistor. See the resistor or not? Resistor mean charging or discharging? Resistor mean discharging, no? Describe the change in the total energy stored in the system with the time. So now, when the thing is, the thing will be discharging, right? You need to explain. Describe mean you need to tell the teacher that what you get the answer from here. So you write here, first one is say the, I use the wrong pen. So you see the capacitor will be discharged. The capacitor will be discharged. Okay, so they say total charge. Total charge, because they ask you about the total charge. What happened? Total charge decreases exponentially. Exponentially. Exponential means the thing decrease by that. This is called exponential. Yes, the one is called the description, how to find the chain. So normally if you write the point here, you got 2 point, 1.1 mark. So 2.2 marks. Okay, there's a model answer that we can share with you lah. Alright. Okay, the one is a capacitor. Of course, got many questions. I cannot share with you so many. You just go through by yourself, right? So teacher only guide you how to go through the revision at home. I said not, then the thing will getting better. So we go to the syllabus again. We go to number 3. It's about electric current. Yeah, topic number 3, or we call topic 14 about electric current. Okay, electric current, of course, you see the 14.1 conduction electricity. Electric current, of course, is defined. You must say the rate. Electric current defined as the rate of charge flow. Yes, define electric current is the rate of charge flow. So use the formula I equal to dq dt. So try to write the answer I equal to dq dt. Some written at I equal to q per t. Q per t sometimes is not so accepted. They prefer you write in differentiate differentiate shape. So dq dt, right? Because it's a rate of charge flow. Okay. Explain the mechanism of conduction of the electricity. Conduction electricity in metal. So for metal one, it means before we apply the electric field, electron is moving, right? Is moving in the random motion, is or not? Random motion. So the keyword for this conduction, because of what? So in metal, it consists of many free electrons. So remember the word I write, free electron is a keyword. Especially the word free. It must write free electron. Don't say electrons only. If you never write electron, I tell you will lose maybe 2 or 3 marks. Because we must make sure the electron is free to move. So you must mention free electrons. Yeah, no matter you say the free electron collide with the lattice atom, how the free electron drift from negative terminal to positive terminal, something like that, right? So the word must be free electrons. The phrase must be free electrons. And then of course, before apply the electric field, the motion we call random motion. Yes or not? It's called random motion. So random motion, that means is because of what? Because the electron moving by random motion, mainly because of temperature. Is it correct? Because the temperature, the free electron is moving in random motion. Random motion means it's going in any direction. Right? Typically, the value for random motion, the speed, it can be go to 10 to the power of 5. Example for copper, as you know. The electron motion, it can be random to 10 to the power of 5 meter per second. Okay, that is called the mechanism in metal. Alright, after that, 14.2 about drift velocity. Drift velocity is a concept of this one. Drift velocity is actually, you explain the concept. That means you must tell the teacher that what is different between drift velocity and the random speed. So that means you must say random speed is because of temperature. Without you apply electric field. Yeah, so after you apply electric field, so the speed we call drift velocity. So that means the drift velocity is called average velocity of the free electron when potential difference is applied across the terminal. Yeah, is average velocity of the free electron when potential difference is applied across the terminal. So we call drift velocity. Okay, then need to derive the formula for this NAVE here. So let me need to derive how you get the formula for NAVE. So by using the formula dQdt, So this is a formula to calculate the drift velocity and so on. So highlight the formula NAVE. Yes, so normally you derive here by using the formula I equal to dQdt, yes or no? I equal to dQdt. So we know from here, your Q will equal to NE, yes or not? Is NE, is NE. Then we must relate to the small n. The small n will equal to the big N divided by volume, yes or not? So finally, it is the numbers of carrier per volume will stand for AL. Right? So finally, you put there, your big N will equal to the N multiplied by AL. L is the length of the conductor lah. So finally, the I become dQ is given by NE. So it's a NAL multiplied by E lah, divided by time. Yeah. So the I become NABE. So where the L per T stand for your drift velocity. Okay. So this one is the derivation of the drift velocity. You can refer to the text. So after derive, can use the equation NAVE. Okay, define electric current density. Current density is a symbol given by J, J, and then also conductivity. So what is a current density? Given by is a current per unit cross-sectional area. Yeah, because the J equal to I per A. Remember? I per A, so given by current per unit cross-sectional area is called current density. Yeah, current density. Alright, so what is the conductivity? So conductivity actually is the reverse of the resistivity. Is it not? So conductivity actually is a sigma. Sigma actually equal to 1 over rho. 1 per rho. So actually conductivity is how good it can conduct electricity. It's called conductivity. Ability to conduct electricity. Right? We call conductivity. Okay, use the relationship J equal to sigma E. There's a one sigma E here. So the J equal to sigma E stand for current density. Sigma stand for conductivity. E for electric field. Alright, electric field strength. So this one need to how to use. So the J equal to formula for J is I per A, right? J also equal to NVE. And because NAV divided by A, the A cancel, become NVE. Okay, there's a one. Then G derive use the equation sigma is NE square T per M. This is also important formula for this conduction for electricity. So you look at the symbol there. Sigma stand for conductivity. N stand for numbers of charge carrier per unit volume. E stand for the carrier charge. The T is called mean free time. So what is the mean free time? So mean free time is the average time taken between the collision of free electron and the lattice atom. We call mean free time. And this is a mass. This is called the mass of the charge carrier. So charge carrier including free electron or maybe is a positive charge. Example, in this semiconductor, you get the two types of charge carrier. One is a free electron, one is a hole. You know holes? Hole means considered positive charge carrier. So negative charge carrier consider free electron. So M stands for mass of charge carriers. Okay, so sigma is NE square T per M. You need to how to derive. Derive from there. So define resistivity. So resistivity actually equal to your resistivity actually the ability to resist the current from flowing. Because this one is the inverse with the conductivity. So conductivity is the ability to conduct, to allow the current to flow. Resistivity is the ability to resist the current from flowing. Resist. means to stop the current from flowing. All right. Okay, use the formula. Sigma is RA per L. So this one, the formula relate resistivity and resistance. Actually, you can see from the resistance formula, because resistance depends the resistance the conductor depends on what? So resistance conductor depends on length, you know? Also depends on cross-sectional area. The longer the length, the higher the resistance. The bigger the area, the lower the resistance, right? Okay. So this one is a relationship. So how to make it a equation? We put the formula there. R equal to rho L per A. So finally, you can see this one. Is why the sigma equal to RA per L. Yeah. So that means this is the equation between the sigma, the rho and also the R. Yes, that one is called your resistivity. Unit for resistivity, we use the ohm meter for resistivity. Okay, show that the equivalent between Ohm's law and the duration J is a sigma E. So J is equal to sigma E stand for Ohm's law also. You need to prove why is the same. Why are they the same? So from here, J equal to sigma E. So we know the J is a sigma E. Then the J given by I per A equal to sigma. Electric field is a V per L. Yeah. So from here, you can see your V per I. V per I will equal to the L over sigma A. Yes. So then you can see where your L, the sigma and A, consider they are constant. When they are constant, we can see the V per I will equal to a constant. So that means the V proportional to the current. Yes, when the V proportional to the current, this one refer to what law? So this is the Ohm's law. Okay, that means you can say actually the J equal to sigma E refer to Ohm's law. Okay, so this is how we show Ohm's law is followed by this J equal to sigma E. Sigma stands for conductivity. Okay, then part J, explain the dependence of the resistivity on the temperature for metal and semicon by using this formula. So this one also important about resistivity on temperature. So using the formula, sigma is Ne square T per M. Yes or no? So from here, you can explain by using this phenomena, Ne square T per M. So example for temperature, let's say for metal case, when temperature higher, so what happened to the atom vibration? When temperature higher, the lattice atom vibrate more vigorously. You know, so that means the collision between the free electron and the atom become more frequent. Okay, that's why the mean free time will decrease. Right? When mean free time decrease, it got smaller conductivity, so it got higher resistivity. So for temperature, for metal, temperature higher, we got higher resistivity. Whereas for semiconductor, when temperature higher, so the same thing happen, no? You got the the atoms vibrate more vigorously, collision also happen more. You got smaller mean free time, you got smaller conductivity, you got higher resistivity. But another effect also come in. For semiconductor, when temperature higher, it can release certain electron because of the weakly bond one. So that means release more electron to the semicon, the numbers of carrier become bigger. In numbers of carrier become bigger, we got bigger conductivity. That's why we got smaller resistivity. Okay, so now you got the conflicts happen here. First phenomena, the resistivity increases. Second phenomena, it decreases. So which one is more dominant? So according to the result here, the second phenomena is more dominant. So more dominant means is more obvious. So you follow the second one. When temperature higher for semiconductor, you got lower resistivity. Okay, so there is how we explain the temperature depends on the metal or semicon or any metal or semicon between these two material, right? One is for metal conductor, one is a semiconductor. Okay, and the last one for chapter 3 discuss the effect of temperature change on the resistivity of conductor. So this one, of course, you need to explain. You can use a graph, yes or no? So there's a graph you can see for conductor, semicon, and superconductor. Normally, the graph that I show to the student will be sketching like that. You're given this one is your resistivity against the temperature. So maybe the graph is a little bit curved. This one is for metal. Mean that when temperature higher, we got higher resistivity. Then the curve belongs to semiconductor. So that means when the temperature higher, I got lower resistivity. And then this special graph refer to superconductor. Right? This one for superconductor. Superconductor is one of the conductor that perform zero resistance under certain temperature. Yeah, superconductor will perform zero resistance under certain temperature. I mean below certain temperature. So the certain temperature we call critical temperature. So when the temperature can go to below critical temperature, the conductor becomes superconductor. Example for mercury, the temperature can go to temperature can go to 4 Kelvin. So 4 Kelvin is very small, around negative 269 degrees Celsius. Of course, now got a lot of superconductor, right? It's alloy, a mixture of the conductor to produce a supercon. Okay, so there's a graph for this current. Yes, so briefly, there's about the explanation for this supercon and then also electric current. So now we go to one question about this. I prepare for you. Also about, because I try to choose every topic one question at least we try lah. Right? You cannot finish, of course. Maybe you can go back to the school and the teacher will revise for you. Of course, you got many specialized teacher around you, you know. Yeah. Okay, so now for this case, you look at the question for this electric current. All right, heating coil of the 1000 kilowatt is designed to operate from the power supply 240 volt at the room temperature. The coil is made of nichrome wire diameter 0.5 millimeter. Okay, look at this data given to you. You can see, yeah, this one 1.00 mean is a 3 significant, no? So this one is also 3. This one is a 2 significant, including this also 3 significant. All right, so of course the answer can be 2 or 3 significant. Follow the minimum one. All right, so now calculate the length of the nichrome wire. So you are given the power, you are given voltage, you are given the diameter. All right, so need to find the resistance first using the power formula. Power equal to V squared per R. Yeah, because power is IV. It can be V squared per R, can be I squared R. So since you are given voltage, yeah, you are given power. So can find the resistance using V squared per P. So V is a 240 square divided power is a 1000, 1K lah, right? So this answer you get 57.6. I just shared the answer with you lah. If you have any question, you can check yourself. Yeah, 57.6 ohm. After that, you want to find the length of the wire. We know the resistance is equal to rho L per A, yes or no? So that means the L must equal to RA per rho. So sub the value, resistance 57.6, area given by pi R square, is it? Pi R square. So from here, you use the diameter 0.5, your radius is 0.25, convert to meter, then square it, then divide by resistivity 1.5 to the power minus 6. So that means you make a habit that this millimeter must convert to meter. Then normally the question give you diameter, but you want the radius, so need to divide by 2. Then don't forget to square it because it's the pi R square. Alright, so the L length of the wire given by 7.54 meter. Okay, so there is a final answer. You can make it 7.5 or 7.54 meter. So normally 3 significant is safest for you. Alright. Okay, now number B, explain the effect of the temperature increase on the power dissipated by the coil. So that means what happened to this power dissipated when the temperature increase. So dissipated power go to I squared R here. Yeah. So temperature increase, what happened to your resistivity? So for this case, we know already, for this coil considered as a metal. So that means when temperature become higher, so your resistivity increase or not? Is a resistivity of the coil increases. When increases already, the current flow should be decreases. Okay? Because resistance relate to resistance. So once the resistance become bigger, you got smaller current. Right? With small current, you look at the formula from here, I squared R. Yes or no? Because of the I squared, the power is bigger. I squared R. That's why the power dissipated decreases. Okay? So everyone will give you 1 mark for this. So you might explain about resistivity, explain about the current, finally about the power dissipated in this case. Alright, so there's the one that the question for this structure normally is a short question. I can show you that mostly is about calculation. So you must master the formula very well. And then you must explain about certain thing. So look at the word the teacher tell you in the answering skill. Explain the effect. So need to tell what happened. What happened to the power when the resistance become higher and so on. Alright. Okay, so that one is here. So the syllabus that we cover, I think we can cover only 3 topics for today because I think I finished, but the time is the rest you can continue by yourself. This one DC, right? And then DC, you go through the syllabus, try to write the formula and also definition. So for me, this one become your revision list, you know? So I always ask my student to do this one in the class. So maybe go back, I also do to my student to show them how to prepare the list by themselves. So the list of these become the main reference of the material, you know? Yeah, so that means you can go through the syllabus, direct current, okay? Then you got the magnetic field, okay? Then you got the magnetic induction. Course teacher cannot, I'm not good in predict the question that come out because I don't want to give you the false hope about this. So for me, rather than go and predict the question, you better spend your time to do revision on this, enhance your fundamental, and of course everything will be followed according to the syllabus. So for me, if you follow the syllabus and then you master all the skill here, of course you can answer the question, no matter what kind of question come out. As well, this is a tips that teacher can share with you for today. Alright, okay, I think it's almost 4:55. I think I can we can go back to our moderator.
Okey, terima kasih Cikgu KHOO
Yeah.
atas penyampaian yang sangat hebat dan penuh ilmiah tadi. Saya harap semoga pelajar-pelajar kita tadi dapat mendapat ilmu yang bermanfaat dari apa yang telah dibicarakan tadi. Okey, jadi sebarang jika ada kemusykilan ataupun masalah, boleh je hubungi Cikgu KHOO untuk mendapatkan maklumat lanjut. Jadi sebelum saya mengakhiri ini, sebab kita pun dah sampai penghujung, jadi sebelum kita berakhir, mari kita sama-sama saksikan tayangan video mengenai MMU sebagai penutup kita punya seminar hari ini. Jadi sebelum kita berakhir, saya ingin meminta maaf dan ampun dan maaf kalau ada salah silap tadi. Jadi sebagai penutup, terimalah serangkap pantun dari saya. Okey, Makcik Nalini membeli selasih. Sik-sik Nandri, terima kasih. Wabillahi taufik wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.